Alright, this is our first video for the new installment of Work, Energy, and Power. So we already have three equations up on the board. The first one says work is equal to force times distance. We also know that force is the product of just mass and acceleration. So it's just another way to write it. And then the third one down here is the one you'll see on your equation sheet, where work is equal to force times distance times the cosine of theta. Well, if we just have a force of 5 newtons, and that 5 Newton force is going to act on a block for a total of 12 meters, then the work is just equal to force times distance. So 5 times 12 would just be 60 joules. Easy peasy. For us, we're going to complicate things a little bit. Let's say that I have a larger force of 50 newtons, but it's pulling at an angle of 45 degrees above the horizon. And we're going to pull this block a total of 10 meters. So this is where I need to use the full equation on my sheet, because I can only take the component of the force that is parallel to the direction of motion. So here we just take 50 newtons times the distance of 10 meters times the cosine of 45 degrees. Make sure you're in degrees and not in those filthy radians. And when you put it all together in your calculator, you should have got a total answer of 262 joules. It is important to note that work only counts for the force parallel to the direction of motion. Let's look at a more complicated problem. Here I have an angle of 30 degrees. I have a 3.0 kilogram block that is a 20 Newton force acting on it, and it's gonna go a total of 18 meters up this inclined plane. So at first I want to know the work done on the block. What is the work done on the block? Well, work is just equal to force times distance. So even though they give you all this other information, and you'll see problems like this in the not too distant future, they give you an angle here. Is this angle, does it really matter for this problem? Do I have a force that's parallel in the direction of motion? Yes. Do I have a distance that the object is traveling which is true to its linear displacement? Yes, I have both of those items that I need to find the work. So all I have to do is just multiply 20 newtons times 18 meters, and I get 360 joules. The fact that this angle is here, or I have the mass of the block, doesn't matter in this problem. I'm only looking to find the work done. So I'm looking for the force that's applied parallel to the direction of motion, and I need to know the total distance, linear displacement, that the object has moved. Those are the only two things that I need for work. Keeping along those lines, the last part of work, and here's the other trick question that you're going to see, is let's say there's a ball at the end of a string that's moving around in a circular path. Well, what do we say? That the direction of motion is this way, so direction of motion, and the force is the force of tension, which is inward. The force and the direction of motion are perpendicular to each other. So there is no force that is parallel to the direction of motion. So if there's no force parallel to the direction of motion, then there is no work. So anytime something's moving in a circle, what is the total work done on it? It will always be